Hello everybody. Today we will start with a new chapter of chemistry, that is hydrogen chloride. So that is one of the part of the big chapter, that is study of compounds. So we are going to study 4 compounds in this particular year. One will be hydrogen chloride, another will be ammonia, nitric acid and sulfuric acid. So out of which there are 3 acids and 1 bases, and that is one of the reason I took the acid, bases and salts chapter earlier to this particular session, so that you have the general idea about what are acids. So understanding HCl and ammonia and all becomes easier once you have the general idea about what are acids and what are bases. So we start with the first chapter, that is of study of compounds, that is hydrogen chloride. Now the hydrogen chloride over here is divided into, I would say, 2 parts, because hydrogen chloride exists in 2 forms. One is in a form of a gas, that is HCl gas. Now this HCl gas is not an acid, okay? It's a neutral gas. Whereas when this HCl gas comes in contact with water, that H3O, that is hydrogen ion formation, takes place, due to which the HCl gas gets converted into HCl acid. So that's why we'll first, in the first part of the chapter, we will understand about HCl gases, and we'll understand that how HCl gas is being prepared and how it is being useful, its properties, chemical properties and physical properties, and then we will go to the next part, that is HCl as an acid. So first of all, discovery wise, remember then in this particular chapters of the discovery occurrence are not the questions which are normally asked in the board, so you may easily skip those. They may not be learned completely. The main thing what is going to be asked will be much more about the preparation, the industrial preparation if any, or in the physical and the chemical properties. Even the uses are not so important. So the main thing will be the preparation, physical and chemical properties, which are going to be more important. Anyway, in this video we'll go through the complete chapter right from discovery to the uses. So solution of hydrogen chloride gas was named muriatic acid, and in 1648 Glauber prepared HCl gas from rock salt and concentrated sulfuric acid. So it was in 1648. Okay, that's a huge, it's sort of 400, more than 450 years. So beyond that much time, it was Glauber who prepared HCl gas from rock salt and concentrated sulfuric acid. In 1972, Joseph Priestley obtained it in the pure form and named its solution marine acid, which was later named muriatic acid by Lavoisier. So Lavoisier named it muriatic acid, but initially it was marine acid, which was in 1772 given by Joseph Priestley. And finally, it was 1810 Davy gave the name hydrogen chloride, because it was then when hydrogen, chlorine and everything was properly discovered, and we had the proper name that these are elements. Till that time in 1648 and 1770, we never had that much amount of differentiation between the different elements what are there. So that's why it was only in 1810 that Davy named it as hydrogen chloride, taking it as a combination of hydrogen and chlorine. Occurrence wise, hydrogen chloride occurs in the free state. HCl gas occurs in free state in volcanic gases and in gastric juice of mammals. So that is the main thing. It's occurrence. Occurrence in the nature, you won't find HCl directly available anywhere. But yes, in case of volcanic eruptions, wherever the volcanic eruptions take place, in the volcanic gases, HCl is a part of the gases which are going to be given out by the volcanic gases. So in nature, volcanic gases will have it. And the main thing, gastric juice in our stomach, okay, the gastric juice in our stomach contains HCl. So we ourselves, our body produces HCl in our body, though that is in the form of gastric juice. Now, very important here, due to difference in electronegativity of H and Cl, the bond in HCl is polar covalent. Okay, it is that particular kind of a valency, covalent bond, wherein HCl में Cl has got a more electronegativity than H, and hence because the difference in electronegativity is very high, the shared pairs of electrons are much more attracted towards the chlorine than in hydrogen, and hence chlorine gets a differential negative charge, hydrogen gets a differential positive charge. So it will be this way, that if this is H and this is Cl, this is 1, 2, 3, 4, 5, 6, 7, and this is your X over here, it is going to be so that this X and all will be almost like that, this will become like delta positive, and Cl will become like this. It will be 1, 2, 3, 4, 5, 6, 7, and this will become delta negative. Hence this is a polar covalent bond, okay, compound. So the compound which is formed by this two is a polar covalent compound, right? So that is the main part over here, that polar covalency is going to take place over here. Preparation. So now we come to the main part of the chapter, that is preparation of HCl. Now preparation of HCl can be done by two methods. One is by direct combination. So yes, I can take hydrogen, chlorine, mix together, hydrogen chloride. So yeah, the first thing is moist hydrogen gas combined with chlorine in the presence of diffuse sunlight. Okay, so we have the equation as H2 plus Cl2 in the presence of diffused sunlight. We get it as HCl. So it will be 2HCl over here. So this is the first method. You are going to take moist hydrogen gas combined with chlorine in the presence of diffuse sunlight to give you HCl. The reaction is explosive in direct sunlight. We are using diffuse sunlight. Okay, what do you mean by diffuse sunlight? Directly sunlight is not available. Sunlight is there, means it is the daytime. Okay, the sunlight will be there. You are not going to do it, operate it, or do this condition directly on the window pane where the sunlight is coming directly. You are going to shift it inside where the sunlight is going to be coming, but in not a direct sunlight. So if you use a direct sunlight, then this particular reaction could become very, very vigorous and becomes explosive in nature. Hence, so negligible, it will be negligible in dark, and moisture acts as a catalyst in the above synthesis reaction. So in this case, first condition is diffuse sunlight. Second thing is that dark may, it is not going to happen. It is going to be very, very less amount of negligible in case of darkness. And moisture, the moisture in the atmosphere, the moisture around, that is why we are taking moist hydrogen gas. Okay, so similarly, moisture over here is acting as a catalyst. It is making this synthesis reaction much faster. Burning jet of hydrogen also burns in chlorine, forming hydrogen chloride. So hydrogen, if it is burned and chlorine is passed through it, then also we can get the same particular thing. So yes, that is another method of production of direct combination over here. The another one is the reaction of metallic chloride with concentrated sulfuric acid. So we have a metallic chloride, that is we are going to take metallic chloride plus concentrated H2SO4. I'll better write it here so that I can use it properly. So we have over here that NaCl plus concentrated H2SO4 is going to give me NaHSO4 plus HCl. So this is the reaction which is going to take place. Now over here, this reaction is going to take place at a temperature which is less than 200 degrees Celsius. Temperature less than 200 degrees Celsius. It is going to give me this particular NaHSO4. That means sodium bisulfate is going to be released, given out, and HCl gas is going to be given out. So this will be in the form of a gas. So it will be G like this. HCl gas will be taken. Concentrated, very important thing over here is we are using concentrated sulfuric acid. We have learned that it was a non-volatile acid. Being non-volatile in nature, it helps in the production of other acidic gases. So that's why we are using concentrated. So let us see this whole reaction, let us see in detail as a laboratory preparation. So let's go through the laboratory preparation now. So the laboratory preparation, you first of all have this equation. So write the equation once again. That will be NaCl plus H2SO4 concentrated, and it will give me at temperature less than 200 degrees Celsius NaHSO4 plus HCl gas. Okay, now over here what we are taking will be a flask, a round bottom flask, and in this round bottom flask we are going to take the solution of NaCl. So we are going to take over here NaCl in a solution form. Okay, aqueous solution of NaCl will be taken over here, that is rock salt, and this particular thing is going to be fixed with two knobs. That is, one will be having a thistle funnel and another will be the delivery tube. Okay, so this will be the delivery tube. Okay, now this thing we are going to place it and heat this particular mixture. Okay, so what we are taking over here will be, we are taking sodium chloride and we are pouring from here concentrated H2SO4. Concentrated sulfuric acid is being poured into this flask and NaCl is taken over here. So NaCl is taken and we are going to take you are going to take NaCl, that is rock salt, and we are going to take sulfuric acid. So we are not taking an aqueous solution of NaCl, we are just taking NaCl, and we are taking we are just taking rock salt, NaCl, and we are taking the sulfuric acid. So first of all, the reaction. Now the same reaction, if I would have taken the temperature greater than 200 degrees Celsius, then the resultant will change only slightly. That is, Na2SO4 will be formed and HCl will be formed over here. So 2HCl will be formed over here. Otherwise, so the difference is, this is bisulfate and this is sulfate. We'll understand this thing much better, that which is more better, which condition is more better, this one and this one. We'll just take up in the later part of the chapter. So first thing, reactants are sodium chloride NaCl and concentrated sulfuric acid H2SO4. Products will be sodium bisulfate and hydrogen chloride gas. Procedure wise, the reactant sodium chloride and concentrated sulfuric acid are initially slowly heated. Observation: the HCl gas observed in the round bottom flask X passes through the delivery tube, bubbles through the drying agent in the washer bottle A, and the dry gas is then collected in the jar. So I just made the half a thing. So here it is then going to be passing through a bottle which is called as the washer bottle. This washer bottle is the one which is going to absorb the moisture from this particular gas. So that's why we are going to pass it this way, that we are going to make it pass through a drying agent. This drying agent over here is nothing but again concentrated sulfuric acid. This is conc sulfuric acid. We had learned in the drying agent and the dehydrating agent that sulfuric acid is a very good drying agent. So that's why we are using concentrated sulfuric acid over here. If you remember, in the dehydrating delicacy was a था उसके अंदर salts में we learned that drying agent में H2SO4 is a very good drying agent. So what will happen? As soon as the reaction starts, the bubbles out, the effervescence is there and the gases is going to come out from here. It passes here, goes into the washer bottle. Inside the washer bottle it is going to bubble up. What will happen? Whatever is the water vapor in that gas is going to be absorbed by H2SO4 because it's a drying agent. See, H2SO4 does not react with HCl, but H2SO4 will absorb the water which is going to be generated because of some impurities over here. So that moisture which is coming up over here is going to be taken up over here, and that after that the gas which is going to be coming out will be a dry gas. Now, so we are going to get a dry gas of HCl given out. Now is the next thing is how do we collect it? So we are going to collect it in a very simple method, and that is by upward displacement of air. So air is going to go out and HCl will be formed here. Why? Because HCl is heavier than air, and I cannot use water over here because HCl is highly soluble in water. Okay, HCl is very much quickly soluble in water. It means the solubility is so high that in just 1 volume of water there would be around 400 volumes of HCl which can dissolve in it. So it has got a high solubility. That's why we cannot use water over here. If you want gas, we cannot use water over here. What we are using here is just simple air because it doesn't get mixed with the air, and so HCl is going to come inside. HCl being heavier is settling down inside the flask, and whatever air is there is going to come outside. So that's why the method of this particular collection is called as the upward displacement of air. Okay, it's called as the upward displacement of air. This particular process of collection, the collection method is upward displacement of air. So what is upward displacement of air? Why is it used? Because of two reasons. Firstly, with air being heavier, HCl being heavier, it is going to settle down in the curve and air is going to be removed. Secondly, we cannot use water because HCl gas is highly soluble in water. Because it is highly soluble, we cannot use water. So in this way, we can see the observation wise, the HCl gas obtained in the round bottom flask X passes through the delivery tube, bubbles through the drying agent in the washer bottle A, and dry gas is then collected in the gas jar. Okay, so we are collecting it in the gas jar as a dry gas because यहाँ से जो भी गैस आया उसके अंदर थोड़ा वाटर वेपर था. That water vapor got absorbed in the concentrated sulfuric acid and then it went into the flask as a dry gas. Purification by passage through washer bottle A containing drying agent concentrated sulfuric acid which absorbs moisture. I told you this is a washer bottle A. This is nothing but a washer bottle A which has the drying agent concentrated sulfuric acid. Now precautions. Reaction mixture is initially heated very slowly to control the evolution of HCl gas. So first thing is that you are not going to heat it immediately very fast because otherwise HCl gas which will be generated will be in a very high quantity. We will not be able to control it. So that is one thing. Secondly, the lower end of the thistle funnel should dip below the acid in flask X. Otherwise the HCl gas obtained will escape out through the thistle funnel. Now this is important. We can see that I have drawn it such a way that the thistle funnel is dipped inside the HCl, inside this particular H2SO4 acid. I did not place it just over here. I did not place it like this. If I place it like this, what will happen? While pouring, it's not a problem. Whatever HCl is going to be generated, it may not go only through that, it will go even from here and there will be HCl gas coming out from the thistle funnel. Right? So to avoid that thing, this thistle funnel should be placed in such a way that it is. So before you start heating it, the thistle funnel should be placed in such a way that H2SO4 which is available over here, uske andar ye thistle funnel dipped hai. So that the gases cannot enter from here out. They cannot go from here. They have to pass through this part only. Now, so collection is dry hydrogen chloride gas is collected by the upward displacement of air because it is heavier than air. It is highly soluble in water, hence not collected over water. I told you that it is by upward displacement of air because it is heavier than air, and secondly it is not collected over water because it is highly soluble in water. Identification. Now how do I know? Now this HCl gas is a colorless gas. I cannot see that gas. तो मुझे कैसे पता चलेगा कि इसके अंदर ये neither I can see air. So मुझे यहाँ पे something is going to be generated. I know that something is being generated because there will be bubbles over here and bubbles over here. But that bubble I can see that okay हाँ कुछ तो generate हो रहा है. But how do I know that this gas jar which I have taken is going to be filled with HCl or not? Okay, और यहाँ तक भरा के नहीं भरा. I can just or else it will just happen that this gas overflows and it will overflow and I don't even know that it is overflowed. For this, what we are doing is we take a glass rod. We dip the glass rod in ammonia. Okay, we take it in ammonium solution. So we are going to dip it in ammonia solution, and that ammonia solution से dip किया हुआ glass rod हम लोग यहाँ पे इधर place करेंगे. So ammonia, when it reacts with HCl, it is going to give you ammonium chloride. It is this way. NH3 plus HCl gives me NH4Cl. Now this reaction, this NH4Cl is dense white fumes. So what will happen? As soon as I place it over here and when the air has escaped out completely, till the time air is over here, there is no fumes coming from this particular glass rod. The moment the HCl is completely filled over here and it comes in contact with the ammonium solution, it is going to give out dense white fumes. So the moment it gives me dense white fumes, I know that this glass jar is filled up, it's completely filled. I either replace it with something or I may even stop this particular experiment altogether. So a glass jar dipped in ammonia solution is brought near the mouth of the gas jar. Why? If the gas jar is full with the hydrogen chloride gas, then dense white fumes of ammonium chloride are formed. So we will find that dense white fumes of ammonium chloride will be formed as soon as the gas jar is filled up. So now let us go in detail about the reactants and the products which are going to be formed in this experiment, so that whatever any important exceptions or any important give reason questions could be asked can be understood very easily. So first one is the metallic chloride preferred for use in NaCl and the acid concentrated sulfuric acid. So why? See, the first thing is that okay, I just told you use NaCl, use concentrated sulfuric acid. But कभी तो कोई तो सोचा रहेगा ना, क्यों? Why NaCl? Why not something else? Why not calcium chloride? I want a chlorine. I want chloride gas. So, कोई भी chlorine चलना चाहिए ना. Why specifically NaCl? So that's a question. Sodium chloride is preferred in the laboratory preparation of HCl since it is cheap and easily available. सबसे सस्ता. Okay, rock salt. अरे की गर्मी होगा. So, because it is very easily and cheap, that's the reason we are taking NaCl as the reactant. Okay. Now comes concentrated sulfuric acid. वो क्यों? So it is a non-volatile. I told you, concentrated sulfuric acid is a non-volatile acid, means it reacts slowly. So and has a high boiling point. So what are the two things? It is non-volatile and it has got a high boiling point. So what happens? It hence displaces the volatile hydrogen chloride. This is the volatile layer. So because it is slow reaction, so it is displacing this HCl gas from the sodium chloride thing. Okay, so that is how, because it is reaction is slow, so that the volatile content जो है वो immediately निकलने के बाद में react नहीं करेगा और वो उसको time देगा generate होने के लिए. So that is how we are using concentrated sulfuric acid. Concentrated nitric acid cannot be used. Why? Okay, वही है ना कि why not a volatile acid over here? So that's the answer to this. In place of concentrated H2SO4, since it cannot be used, since it is volatile and may volatilize out along with the hydrogen chloride. So the moment you are generating, because it is volatile means क्या होगा? वो खुद भी react करने लगेगा, वो खुद भी अपना NO2 वगैरह form होने लग जाएगा, because it is volatile in nature. So that's the reason, along with the HCl, we will also get the fumes of HNO3. So in this way, volatile acids, they are going to form their own vapors also, or they will volatilize out along with HCl, and hence it is necessary for us to use only those substances like concentrated sulfuric acid. In fact, there is the only one, concentrated sulfuric acid, which is a non-volatile acid and has a high boiling point. बिकॉज अगर लो बॉइलिंग पॉइंट है तो भी प्रॉब्लम है, इट विल वॉलेटाइज अगेन लो बॉइलिंग पॉइंट है तो इट विल वेपराइज, नॉट वॉलेटाइज, इट विल वेपराइज, सो यू डोंट वांट दैट थिंग आल्सो टू हैपन, सो दैट्स व्हाई यू आर यूजिंग concentrated sulfuric acid. Now we talk about the temperature. I told you these are the two reactions. So why this is preferred and why not this preferred? So that is what we are learning now. The temperature in the laboratory preparation is properly controlled at a temperature less than around 200 degrees Celsius. Sodium chloride and sulfuric acid are going to give me sodium bicarbonate. So whereas when you are taking above 200 degrees, I can see it is going to give me sodium sulfate, sodium not bisulfate. It is going to give me sodium bisulfate in the first case, less than 200 degrees Celsius. More than 200 degrees Celsius, it is going to give me sodium sulfate. So what is the difference and what is the better thing? First thing, if I am using more than 200 degrees Celsius, I am wasting fuel. मुझे रिजल्ट तो मिलने ही वाला है, why 200 के ऊपर जाऊं? So first thing, waste of fuel. Secondly, at that high temperature, this glass apparatus may break or crack. So the glass apparatus may tend to crack at such high temperatures. So that is another problem. But the main problem is that sodium sulfate which is formed, it forms a hard crust. So ये reaction होने के बाद में what is going to remain over here? It is only this part which is going to remain inside over here. So this sodium sulfate which is formed will give a hard crust, a white colored hard crust on the flask, which is very difficult to remove. How can you remove? हाथ थोड़ी जाने वाला है उसके अंदर. You cannot remove that thing. So तेरा वो flask बर्बाद. Okay. So that's why that hard crust is very difficult to remove, and hence it is better to use temperature less than 200. So it's a third point is sodium sulfate forms a hard crust, sticks to the glass, and it is difficult to remove. So overall it makes the apparatus non-usable. Okay, you cannot use it further because of the hard crust form. So that's the reason we will always keep the temperature to be less than 200 degrees Celsius, so that the bisulfate which is formed can easily, it is not going to form any kind of hard crust at all, hence it is a right thing to do. Now we talk about the middle part, washer bottle, which has got concentrated sulfuric acid. Again the same question, why not something else? Why not I use subs? There are so much, we learn quicklime and we can calcium chloride or phosphorus pentoxide, कितने सारे नाम हम लोग ने पढ़े थे drying agent के, तो क्यों concentrated sulfuric acid? So let's see that thing. Hydrogen chloride gas obtained is purified by passing through concentrated sulfuric acid. Drying agents used for drying gas should remove only the moisture content to the gas but not react with it. Okay, of course, that's the most important thing. If it so happens that I am using something over here और वो चीज HCl के साथ react करके कुछ अलग मुझे देने वाली है, तो what's the point? I wanted HCl, not something else. So if I use anything which is going to react with the HCl, then I don't find it as purposeful. My purpose was very simple. I have got a moist gas, I want to make it dry. So it should only be able to use as a moisture absorbing compound. It should not react with that compound. So that's it. So drying agent must be such that it should remove only the moisture content of the gas but not react with it. Hence concentrated HCl is used as a drying agent, because drying agent is not like quicklime, phosphorus pentoxide, since they react with hydrogen chloride forming respective chloride. So calcium oxide will give you calcium chloride, phosphorus pentoxide will give you phosphorus oxychloride. So that's the reason you don't use these as the drying agents. We will be using the drying agents as only CaO, or we will be using only concentrated sulfuric acid and not Ca or Pp2O5. Lastly comes the collection method. So you can see in each and every case we are studying why we are using this thing, what we are doing over here, how others will check. If I'm not using this thing and I'm using something else, what is going to happen, what is the reason for using only this thing, and lastly will be why we are using this method for collection of the gas. So it's not only what is done, it is also why it is done. So that's the important thing what we are doing in the 10th standard about these compounds. So hydrogen chloride gas is collected by the upward displacement of air HCl gas is collected by the upward displacement since it is 1.28 times heavier than air, because the vapor density is 18.25, whereas that of air is 14.4. So accordingly, you can see HCl gas is denser than even ammonia, but slightly denser. So that is not required. But mainly we know that it is much denser. It is 1.28 times heavier than air. So we are collecting it by upward displacement air, and gas is not collected over water because since it's highly soluble in water. One volume of water can dissolve 452 volumes. I told you it's more than 400. It's 452 volumes of HCl at ordinary temperature. And then HCl, SO2, H2S, O2, Cl2 and SO2 are heavier than air, while ammonia and hydrogen are lighter than air, and N2 is almost equal to air. So that's the thing. You can just note this down. So whenever you are preparing anything like H2S, SO2, O2, Cl2, you know that it is heavier than air. So you are going to use the upward displacement of air. Whereas if you are taking ammonia or you are taking like something like hydrogen gas, it will be upward displacement. And finally, downward displacement of air. Now finally, HCl, ammonia and SO2 are highly soluble in water, whereas H2S, chlorine and SO2 are fairly soluble in water, while H2, N2 and O2 are slightly soluble. This is just the information you are given, so that whenever you are determining that what is the collection method, so you know if it is soluble in water, you cannot use water, you have to use air only. If it is not soluble in water, then it is better to water, so that you know, you can see water चला गया और gas आया, वो देख सकते हो. यहाँ पे हम लोग को टेस्ट करना पड़ता है. वहाँ पे देख सकते हो that water which was there in the flask has been displaced and the water has gone down and the gas is completely filled in the jar. That can be seen. So visually you can see that thing. That's the reason we normally use water much more than air. But when it is soluble in water, then of course you cannot use them. That's the reason we are given over here that ammonia, hydrogen chloride and sulfur dioxide are highly soluble in water, whereas H2S, Cl2 and CO2 are fairly soluble, whereas H2, N2 and O2 are insoluble. So that was about the preparation of HCl gas. We will now move on to the physical properties of HCl gas in the next video.